What does it? Oh, wait, no, come back here. Give you an explanation. Because from what I was looking up, okay. So sorry about that. I was gonna try to wait until it popped up here. I was just wanting to make sure that because I haven't changed the coding game title. Also, after watching the video, I'm gonna move my microphone a little bit out because you can hear my breathing really bad. So let's see. How's that light too? It's not terrible. Oh, and then the sun explodes. That's all shadowy. Yeah, we'll just keep that. All right. And now, another thing after watching those videos with the new headphones. These are my gaming headphones. So while using these for streaming, I think I'm gonna go back and remake all of the other streams I've made. So Python, JavaScript, Java. I think they all deserve a remake, and we can just consider those original ones next. So we'll do that. Let me go ahead and pull up my little command center down here. So I just wanted to do. Well, we'll see how it goes. Maybe an hour, maybe 2 hours of code clashes. Let's see. We gotta go on the twits. I'm trying to tweet. Let's see, live now. I need to connect this, so I'll be working on that. But it's live now doing coding game clashes on the Twitch. Come hang out to some coding. There we go. I don't know. The marketing part of me likes it, but the rest of me is just like, I hate selling things. So that's why I like the coding game feature where it just automatically. Yep, there we go. And there's me trying to fiddle with the with the blinds. So, anyways, I got my buddies in here. Cool. Um, what's this going on? Oh, okay. All right. Let's pull this back up. Don't worry, we will get to the clash soon. I just got to finish typing this out. I also found a challenge that I want to try. Let's go ahead and pull that. So here's an easy one: horse racing duels. And I think I didn't want to get too deep into it because I want to start film uh, like the coding process from start to finish. So I wanted to not do too much. I've thought through it a little bit, thought through what I want to do for the algorithm. I can already say, in fact, let's go ahead and send that. I'm gonna just throw in a little pseudocode and say, make a loop to compare distances of all the horses. And so that's also going to require us to save the horses. So here's the input. So we're going to have to save the input into a data structure. So even before that, so store horse distances. Okay, so it's like step one, store horse distances, and that'll actually be done here. So, oops. In fact, let me go ahead and do that. We'll do a little bit of this. I know, and we'll get into a clash here soon. So, um, we'll just do distances equals an empty list, and then here we'll do distances dot append pi. Why is it named pi? Oh, position initial? Yeah, I think that's what it means, is position initial or something like that. So, there we go. So that's step one. Basically, yeah, I'll make a loop to compare all distances of the horses. Um, uh, Print lowest distance difference. So, and there's a couple ways to do that too. Originally, I was thinking that I wanted to store all the differences and then make a loop to run through and find the minimum of that. However, you could do it running minimum check when you're storing. Wait a minute. I shouldn't have this as distances. Let's see. Position. We'll do positions and then change it here. Um, there we go. Just kind of make it more clear as to what we're doing. So we have the positions, all the input, and then from there we still need to calculate the smallest distance. So we could even put here min equals 999. Oops, that's got to be equals. All right, so if the distance we find is lower than 999, which, that's why I like to start them ridiculously high, and then we could just do print min. So now all we're missing is the loop to compare, and for that, that kind of delves into permutations and combinations a little bit. Or not combinations, permutations. So it's this plus this, and then also there's let me write a note in here because I was also thinking about this. If else statement for finding distance, and then i.e. max minus min. Although we're using min twice, so just larger minus smaller. There we go. So that just makes a clean way of finding the distances. So you could do it if it's negative. You could do a check after the fact, and so you could do like 3 minus 5. So then the distance is -2, and then you could do a check to say if the distance is less than 0, multiply it by -1, therefore resulting in a positive distance. Because you can't have negative distances. In fact, let's see. Well, yeah. Let's go ahead and see if it says expected 1. Another one expecting 1. Well, there's only 3 test cases? Interesting. Well, anyways, so we're pretty close on this, but let's go ahead and do some clashes, because that's what the title is. So I can come back and do just kind of like a walkthrough. I mean, we pretty much, yeah, we did have, we still need the loop to compare the distances. Like I said, that's more permutation, so you have to check the difference between, oh, let's see, join a clash. While I'm rambling, let's go ahead and finish out that thought. So, oh, polynomial. Well, let's just do some clashing. I don't know how official that is, or what the etiquette is for that. If you see someone on here, invite him to a clash, because he might be doing or he or she. I'm really bad with oh, anyways. Let's do some clashes, and then I'd like to do like a stream where I'm just doing these. So, okay. Reverse mode. You have to guess what to do by observing the provided set of tests. Okay. Square of sum of numbers. That's pretty revealing. So let's go with the smallest one we can find, which looks like this one. So 3 plus 1 plus 3 plus 5, that would be, what, 7, 12? Square of sum of numbers? Whoa. That's not right. Because 81 is not. 8, 9, 10, 11, 12. Yeah, that's 12. So, let's see. Oh, someone already figured it out in JavaScript. Let's do this. Okay, so sum plus equals v print. Well, actually, let's go ahead and leave that. Make our own new one. Print string sum times sum. So this would be that. Is that right? Okay. Wait, 12 times 12 is not, is it? No, because 11 squared is 141. Or, I thought 12 times 12. Well, okay. We got it. Let's go ahead and submit, I guess. Alright, cool. So we got it as well. I mean, a little slower, but I like to be a little more thorough too, because that just didn't seem right. Anyway. Alright, woo. We got 100. And we'll go ahead and leave that. Yeah, twice as long as circle. Do another one. Because I need to get to 50 clashes, so we'll try to do this. I think that's one of my next badges is to get 50 clashes. Nice. Okay, so reverse mode. So we have some tests. Ooh, this looks like an encryption, like a ROT13 or a ROTC or hello world. So it leaves zeros, or leaves those alone. Alright, now, for this, I'm not even going to waste any time. I'm going to, let's see, where is my GitHub? Because I believe I still have it pulled up. Yes. One thing I do not like is to redo these. I've got perfectly good dictionaries that I've written over and over again for such encryption algorithms. Alright, there we go. So that's the basics, and it's very ugly. Let's go ahead and we'll just do that. I mean, it's not. Actually, I don't even like that. No, you want to see all of it. There you go. So you have the number value dictionary and then the letter value dictionary to get the. So it's actually kind of reverse, but either way. So H to F, E. Let's see. H to F, E, F, G, H. So it's -2. Let's see if it's the next one. I to E. So, wait, where are we at? No, it's I to G. E, F, G, H, I. Okay, yeah, so it's -2. So, we're going to do return string equals that. Let's do a loop for char in plain text. Oh, we're missing a opportunity here. Cipher text. There we go. For char -2. Cipher text plus equals. Now this is going to be. It's a two-way conversion. So we get the number. Actually, let's go ahead and I want to separate this out. New char. Oh yeah. New val, or yeah, val equals Oh, and also, these are all uppercase, and these are lowercase, so we're going to do new val equals um, number dictionary of char dot lower. Is it lower or lowercase? I think it's just lower. Alright, so we got that, and then we want to do minus 2. So whatever the number is, we subtract 2. Oh, and then we got to do it circular. Let's see. If new val less than 0, new val plus equals 20. It's either 25 or 26. I think it's 25. I could be wrong, but well, we'll test it. And then new char equals letter dictionary of new val. Okay, and then ciphertext plus equals new char dot upper. See, now we can reuse letter leader. Okay. Oh, whoops. We got to print ciphertext. And what's this? Line 22. We have gibberish. That's right. Okay. Why? 27. Key error. Oh. Alright. So, if char dot lower not in number dict. There we go. Okay. Make sure that's all contained in there. Okay, we're getting something. Found hello world. Okay, so there we go. Nope. What's wrong? Oh, wait a minute.